resolving vectors in just 5 minutes. We've already seen quite a few things about one-dimensional motion in the previous videos. Today we are stepping into two-dimensional motion, and this is the first step that you need to know. Alright, let's start resolving the vectors. How to resolve vector into components? Now first of all, we need to understand that the vector might have some sort of an inclination. So let's take a vector for example, and let's give it some form of inclination. Say this is 45 degrees. And we call this as 45 degrees, right? Now, I see that the angle is right in front of me. The only thing that I need to understand is that a vector has two components, a horizontal component and a vertical component. What is a horizontal component? Something that's horizontal, right? So this, I can denote it as fx. Let me call this vector as f, so this would make it as fx, and the vertical component would be fy. Right? And once I have something in this form of a setup, I can just simply use a simple equation and plug in those values and get the answer, this being my theta, and I can use fx as f cos theta and fy as f sin theta. Plug in the values and I can get what the f would be. This is the horizontal and the vertical components. Now remember that cos theta signifies horizontal component while sin theta signifies vertical component. Okay, that's pretty much simple. But what if you get an angle in such a way that it does not represent the horizontal and vertical components directly? Such as, what if you're given this angle, and let's say this angle is 45 degrees. What would you do then? Well, the answer is very simple. You just got to remember one simple statement. A vector is always a theta away from the horizontal component. You can pause this video and take a note of it. Let me repeat this once again. A vector is an angle away from its horizontal component, which would mean that in this setup, this particular vector is theta 45 degrees away from the horizontal component. So that would mean the vertical line would become the horizontal component in this context, and the other one would become the vertical component. So the vertical component is not something that we find. We always have to look for something called the horizontal component. Once you figure out which form of setup is given to you, you can just simply plug in the values, but the formulas still remain the same. Fx would still be f cos theta and fy would be f sin theta. What is this f? This f right now is signifying a force vector. It could be any vector. It could be velocity. It could be momentum. It could be acceleration, any vector. As long as it's a vector, you could do any of these operations given that it has some sort of an inclination. How about we do this with an example? Calculate the horizontal and vertical component of a 50 Newton force which is acting 40 degrees to the horizontal. So they've given that the vector is 40 degrees to the horizontal. So that would mean I can consider that this as my vector, which is a force component because it's given to be 50 Newton. So let me name it as F equals 50 Newton, and this angle is 40 degrees. What do I know about my horizontal component? That is F cos theta. Right? And my vertical component is Fy, which is F sin theta. I know the theta to be 40 degrees. I have the force to be 50 Newton. So my horizontal component would be 50 cos 40 and my vertical component would be 50 sin 40. I encourage you to try this out and find out what the answer is, and you can comment down these answers below. Now, what if the 40 degrees is on the other side of the vector? So considering this is a vector, this is our vector, and let me consider that the 40 degrees is on the other side, so that would mean the 40 degrees is on the other side. Try out using what we just learned before and see how these answers are different in these two scenarios. If you found this video helpful, make sure to subscribe and hit that like button. The link to this lecture notes and more questions is in the description below. Check that out. I'll see you in another video.